Good evening, students. Uh, this is second class, second lecture of B.Sc series, right? Uh, in first lecture, we have seen that what is organic chemistry, right? And general approach and book, the best books. Some general points already we have discussed about this. Today, we are going to discuss about the chemical reactions in organic chemistry. So, first of all, we must know about the chemical reactions, means chemical changes. The first topic that you have to learn, that what is chemical changes. Chemical changes. First point. So, in class ninth, already you have seen that changes are considered are classified in two categories. First, physical changes, physical changes, and second, chemical changes, chemical changes, right? In physical changes, there is no molecular changes, there is no change in molecular structure and bonding, no change in structure and bonding, structure and bonding. If a change is carried out in such a way that only physical state, color, uh, and some other physical properties are seen to be changed, but there is no molecular changes, there is no change in structure of the molecule, structure of the compound, then such changes are called physical changes. A basic example is H2O. H2O. If uh, you remember that H2O, H2O in liquid state, it can flow, and a fluidity is basic property of liquid water, means water, right? Fluidity, right? But when H2 is just kept in fridge when water is stored at very low temperature, then water molecule goes closer to each other and form a solid uh, state that is called ice. So in liquid state, that is called water, H2O in liquid state is considered as H2O, and also in ice state remains same as H2O, but physical state being changed. Here is a liquid and here is a solid, right? Similarly, a third state is vapor. In vapor stage also, water is exists as a H2O, but in gas phase, not in solid, not in liquid state. So these three states or interconvergence of these states are physical changes, because in all three changes uh, molecule is H2O and H2O, and there is no change in structure of structure and bonding of H2O, right? So this is physical changes. Another is What? Another is chemical changes. So chemical changes means a type of change in which molecular structure, or we can say that a new substance is formed. A fundamental character of physical changes is there is no new substance formed, no new substance, chemically new substance never formed. But in chemical changes, always new substance is formed, new substance formed, new substance formed, always, right? So in chemical changes, a process occur that is called chemical reaction. Chemical reaction. A process occur that is called chemical reaction. Chemical reaction means nothing but only a chemical changes in any substance in which old substance or initial substance form a new substance. New substance, right? New substance have different molecular structure, have different molecular structure, molecular structure and bonding, right? They're totally different from initial, right? Okay, next, see another one. What happen in chemical reactions? The question arises here that why chemical changes occur? Why chemical changes occur? First questions. First question is why question why chemical changes occur, right? So chemical changes occur. This is because if you place a two molecule in a container, closed container, gaseous molecule, if you place gaseous molecule in closed container, then you see that these two molecules are come close to each other and collide, strike to each other, right? In this collision, it may possible that their speed of the both of the molecule will change. Speed changes means energy change, energy change, right? Speed change, it means energy also change, right? What happened in this case? We know that a molecule or a substance, old substance, change to new substance if a minimum energy that is necessary to be supplied in this initial substance when it want to be changed in new one. So minimum energy must be supplied. If their collision provide the sufficient amount of energy that are uh, sufficient to overcome this energy barrier, then this new old substance change to new substance and a chemical change occur, right? So it is necessary to supply a minimum amount of energy. This minimum amount of energy means energy barrier is called activation energy. Activation energy, activation energy, activation energy, right? This activation energy is different for different type of reaction, right? And it depends upon nature of substrate, nature of reactant and temperature, right? And second most important factor is presence of catalyst, right? So these two factors is very important for activation energy. Clear? Now let's see next question in chemical reaction. Next question is why reactions occur? Why reactions occur, right? So here we have seen that reactions occur because the collision of molecules provides sufficient amount of energy that is necessary uh, to change old substance to new substance, means bond breaking or other type of uh, energy requirement. Here you can see that in organic chemistry there are three type of processes by which organic reaction may occur. First, when a molecule that have charge, uh, write this first, charge molecule, like we have uh, Ag plus and Cl minus, right? These both of species have charge, and charge species attract to each other. Both of species attract to it because silver is positive and Cl is minus, means cation attract to anion. In this reaction we know that silver ion silver plus ion is surrounded by electrons, right? Surrounded by electrons like this. Okay, but the attraction between these two provides sufficient energy to overcome the energy barriers, means activation energy, because Az plus have one electron less, less negative energy, negative charge, right? So this attraction come help to overcome the energy barrier, means activate provide energy, activation energy, right? Here the first factor for organic reaction is charge. But a question is here that uh, is all chemical reactions occurs in charge phase? All chemical reactions must have to charge species? So answer is not. All chemical reactions not occur in mm, ionic phase. For example, for example, see here, see here, we have Cn negative plus formaldehyde. Here, here only Cn has charge. There is no charge on formaldehyde molecule, right? But when this charge species, means negative charge, come close to this formaldehyde molecule, then it become polarized. It becomes polarized. Means second requirement is polarization, means dipole. If a reaction do not have any species that has charge, then second process, second pathway to be changed via chemical changes is polarization or dipole, means molecule must have dipole. If they have not changed charges, then they have must have dipole. So here, when negative charge come to this carbon atom, then because oxygen is electronegative, and this attract the pi electron pair, and in this case it becomes O negative and C positive, right? And Cn get attached to this, right? So a second way is polarization, means dipole. Again a question is same, that is it necessary to have or either charge or a dipole? Then question is, answer is no, not dipole always necessary, not charge always necessary. So third way to uh, carry out a chemical changes, to carry out an organic reaction or any reaction, is that it must have, it must interact orbitals. And in a chemical reaction, of orbitals interaction of orbitals interaction of orbitals, right? So third way for a chemical reaction is interaction of orbitals. You know that there are two type of orbitals. First, filled orbitals, and second is empty orbitals, empty orbitals, filled orbital and empty orbitals, filled orbital and empty orbitals, right? So if you want to be carry out a chemical reaction, then your reagents or substance must have two type of orbitals, that is filled orbital and empty orbitals. Means sometime it is LUMO and HOMO, lowest unoccupied molecular orbital, and HOMO. Sometimes these two terms are used, HOMO and LUMO, highest occupied molecular orbital and lowest unoccupied molecular orbitals. Correct? Let's consider. Let's see an example. An example is, why this reaction occur? Why when bromine water is added to ethanol, when bromine water is added to ethanol, CH3, C, when bromine molecule is added to ethane, means acetaldehyde, then color of bromine water discharge fade. Why? Why bromine water becomes decolorized, solution becomes decolorized? So question is, in this reaction, bromine neither bromine have polarity, bromine is non-polar molecule, there is no polarity, but chemical reaction occur. This is because bromine has, if you carefully see the molecular structure of Br2, means MOT diagram of bromine molecule, then you will find that bromine has an non-bonding empty orbital, non-bonding empty orbital. But here, in this case, when bromine attack here, because oxygen has lone pair of high electronegativity, then it attract the pair, pi bond pair, means electron pair of this pi bond, and C have, right? So there will be addition reaction. There will be addition reaction. And another example, a best example, is when bromine Br2 is added to uh, alkene. Means let's we have ethene CH2 double bond CH2. If we have CH2 double bond CH2, because bromine is non-polar already, uh, you have seen, and there is no polarity. This molecule is also non-polar, but chemical reaction occur. Last um, two type of reaction factor you have seen, that either molecule must have charge, either dipole means polar, but in this case both have non polarity, both are non-polar. So chemical reaction, this is because of bromine has non-bonding anti-bonding molecular orbital, empty anti-bonding orbital, and this molecule, if carefully you see, when you break this pi bond, then it becomes like this: CH2 single bond CH2, and both carbon has a pi, means p unhybrid p orbitals, right? Unhybrid p orbit. Okay, one carbon, one out of these two have two electron like this. Okay, this uh, pair of electron is goes to anti-bonding orbital, empty orbital of bromine. If bromine has anti-bonding sigma, anti-bonding orbital, empty orbital, sigma, anti-bonding orbital, then CH2 gives its pair of electron to bromine, anti-bonding sigma star, and form CH2 single bond CH2 and Br, right? So such type of chemical reactions also occur that do not need any type of charge initially, or dipole means polarity, right? So today you have learnt about chemical reaction, by chemical reactions occur, and you have seen, you said that three factors are: first, necessary condition, charge. If charge is not possible, then molecule must show uh, polarity, means they must have dipole. If dipole is also not possible, then molecule must have uh, empty and filled molecular orbital, and this is most important factor. It means chemical reaction may occurs when overlapping between empty molecular orbitals, means orbitals and filled orbitals it interact to each other, right? So these are some basic criteria for chemical reaction. It doesn't mean that this is only for organic chemical reaction. This is fundamental of all type of chemical reactions, because in organic reaction most of reactions are um, carried out in ionic phase because of salt, means ionic nature. But this phenomena, this fundamental rules, these three rules uh, may be applied for all type of chemical reaction, or you can see that all type of chemical reactions occur via these three rules, by using these three rules, right? So